Hello! On the bench in front of me I have a new 3 kilowatt medically approved power supply from XP Power. This is the HPF3K0 series. In this video we will briefly hook it up and look at several of its great features. While I connect the last load cable, it's only a small detail, but the output terminals each have two M5 screws for the cable connections. This could be great for distributing the DC output through multiple wires, or for ensuring that a low resistance contact is made to bus bars when stacking the units for power sharing. It's a nice touch. Another nice touch is that all auxiliary signals have been brought together into a single 30-pin connector. The mating connector housing and crimp are widely available, and the connector style has a positive mechanical latch, which requires a definite action to release the plug again. The product is based upon a digital signal processing engine, or core, which is now common to the HP family of products from XP Power. It's an AC-DC power supply, so fundamentally it is still going to deliver volts and amps, but the digital basis of the product puts the user firmly in control of the product behavior. Many functions have parameters that can be configured through a graphical interface on a computer. Let's look at a typical product application, battery charging, using the power supply as a constant current source. Here is the graphical user interface running on my PC. Lots of useful data is presented on the Monitor tab, and by clicking through to the Configure tab, we can see that many features of the power supply can be modified and adapted by the user. Now I'm going to change the behavior of the overcurrent protection so that it switches from constant voltage to constant current mode at a threshold that I choose. Let's imagine that we want to charge a simulated 12-volt lead acid battery. First, I must disable write protection. I have a 24-volt supply, so I program down the output to 14.1 volts and set a charge rate using the current fault limit of 25 amps. I will also tell the unit what to do when it hits the fault threshold by setting response type to continue operation. I will switch to the Monitor tab again and apply a load greater than the fault current limit, which flips the power supply into constant current mode with the output regulated at 25 amps and the voltage falling to, well, almost nothing to suit the characteristics of our simulated battery. As the battery approaches saturation, the charge current will fall below my current limit set point and the power supply will flip back into constant voltage mode. The digital core of these products puts the user firmly in control of the power supply behavior in two ways. Firstly, many performance parameters can be configured by the user and saved to the internal memory by using the graphical user interface or by sending commands over one of the serial data protocols provided. As the write protect is already turned off, I can save my simple 12-volt battery charging configuration just by clicking Store User All in the interface. This programming permanently changes the behavior of the unit until the factory settings are restored through another button in the interface, or the user modifies and saves the configuration again. Secondly, the user can be firmly in control while the power supply is in use. Real-time dynamic changes can be made through one of the serial data protocols. There's also an analog programming mode which permits full-scale control of the output voltage and current limit set point via 0 to 5 volt linear inputs. Real-time digital control opens up exciting possibilities to integrate these products into digital closed-loop control systems. Let me show you what I mean. If we take electroplating as an example, a voltage programmable DC power source is typically used to deliver the power to the electrodes in the bath, with a current shunt or transducer providing the process variable feedback to the controller. However, an HPF power supply can be integrated into a digital control loop using both the command and the remote monitoring capabilities. I've included just a dotted line here to represent the measurement of the process variable, the current, because this is performed by the power supply and sent back to the master controller over serial data comms. I've anticipated that the error amplifier and the controller would be one integrated digital controller, which is typical today. In addition to the essential control loop function, the HP series power supplies can also provide data useful to a protective maintenance program. Fan speed, internal temperature and other parameters can be monitored, along with variations in output current that might signal an imminent failure of the connected load. Finally, as the HPF3K0 carries medical safety approvals, it integrates well into the areas of medical imaging and surgical robotics. The CANopen serial data protocol is fast and very resilient to noise and errors. Inclusion of this communication bus and the other great control features delivers a 3K product that's ready for integration into the medical systems of today and tomorrow. My name is Alan Hill, and I hope that you found this presentation helpful.